A warm welcome to this discussion where, as the instructor, I would like to respond to some of the discussion that has been taking place on the forum, which I am very happy to see actually. I am first very keen to convey to all of you that having this discussion on the forum is really the purpose of a course like this, because it allows you to learn things from one another in addition to what you learn from all of us. I mean, me as the instructor and all of the teaching associates that are associated with this course. I would actually urge a little more response also from the persons other than those making the first post. So, you will notice that my teaching associates are answering your questions quite keenly, but at the same time they are waiting for a while, because they would like to hear responses from many of you before coming to a point where they respond on their own. So, it is very important. I mean, I do not feel comfortable when I see just one person having posted a discussion item and no one else from among the students has responded. I mean, it is all right, the teaching associates respond at times, but we have responded wherever we think it is immediately important, but at times we have been waiting to actually encourage discussion amongst all of you before we respond immediately. So, please, in future it is very important that when one person makes a post, we would be very happy if other people also responded to that post. And since there are thousands of people really involved in this whole course, do not feel awkward about responding. It does not harm if you say something which is incorrect, because if you write something and somebody else responds to it, both of you learn in the process. The discussion is, after all, not an evaluation at all. So, it is very important that you participate. This is the first message that I wanted to convey to you after looking at the discussion forum. Now, let me go through some of the questions of the discussion forum. So, you will notice that one of the questions that has come repeatedly in this discussion forum is this whole idea of the sifting property, or the idea of selection that is taking place in the. So, let me now draw essentially the unit impulse located at a point t naught again, and there was a very interesting discussion which has now been pinned up about this whole business of the unit impulse and so on. So, you have this very narrow pulse with a width of capital delta and a height of 1 by delta, centered at t0 on the time axis, and you have a continuous function which I am sketching in red and calling x of t. So, this is the unit impulse. Well, it is not really a unit impulse, it is a unit pulse, I should call it. And you can see that if I call this unit pulse, well, delta sub capital delta of t, well, since it is shifted. So, delta sub capital delta of t would look like this. It would be the same thing, but located at 0, and therefore, it goes from minus capital delta by 2 to capital delta by 2. Let us first sketch small delta sub capital delta t, which is a unit pulse around 0, going from minus capital delta by 2 to plus capital delta by 2, and with a height of 1 by delta. Why is it called a unit pulse? Unit, because the unit area is involved here. There is a unit area 1 by delta into delta, which is 1. Now, what we have here is the unit pulse at t0, so to speak, and that is written as delta capital delta t minus t0. Now, you will agree with me that the way I have drawn delta capital delta t here, delta capital delta t is equal to delta capital delta minus t, and therefore, you could switch and write delta subcapital delta T0 minus T here. Both of them have an interpretation. Now, what you also understand, and this is what a lot of people I think have been discussing on the forum, is that if I multiply, if I fix the T0 with fixed T0, the product xt times delta subcapital delta T minus T0 dt integrated over all T essentially gives you this, the value here. You are extracting this part of the function, so to speak, and you are multiplying it by 1 by delta and so on. So, you are essentially looking at this area multiplied by 1 by delta, but remember, when this becomes smaller and smaller, this area also becomes smaller and smaller. So, there is a confusion about that. This green area would tend to 0 if you did not have this height scaling up to 1 by delta. So, ultimately what is going to happen is that essentially when you make this capital delta go to 0, you would have an area of 1 by delta times the value of x at the point T0 times delta. So, delta goes to 0, but 1 by delta tends to infinity. So, it lifts the value of x at the point T0, and this is meaningful if x is continuous at the point T0. If it is not continuous, then one cannot apply this principle at these isolated points of discontinuity. That should be kept in mind. Now, all this is all right, I think, and in fact, you also understood that you could switch. So, you could write delta subcapital delta T minus, T0 minus T, and then you also had a situation where you could interpret the integral the other way. So, you could write x t delta T0 minus T dt integrated over all T is essentially x at T0, and here what I was emphasizing is that there is an important different interpretation that you need to give it. That is that now this holds for all T0 where x is continuous. Now, how do you visualize this? You should visualize it like this. Think of an impulse, a very narrow pulse with capturing an area of 1 located at T0, and visualize T0 moving. So, what you are saying is every time you take a particular position of this impulse, multiply the function x and integrate out, you pick up a particular value of x. And as you keep doing this for different T0, you can reconstruct x at every point. While both these equations are really the same equation per se, when you write it like this, when you write it in this form, the second interpretation becomes important, namely that you can actually move T0 around. The reason why I have written it like this is that later we are going to actually look at this expression. Here you will recognize this as a convolution between xt and delta t notionally. It's a convolution between xt and delta t. You will understand this later, even if you do not understand now. And that is very important, because that will also lead us to a very basic principle that governs linear shift invariant systems. So, it's the same equation written in different ways can help you do different things. Now, that is all fine. I just clarified what all this means, but I do realize that understanding this in continuous time is a little more difficult than understanding it in discrete time. So, what I would like to do before I conclude this discussion session is to actually talk about the discrete time version of this, which will make it much easier for you to understand. So, let us now take the discrete version of this. So, firstly, what do you mean by a discrete sequence or a discrete signal? A discrete signal, I am kind of anticipating, I am going a little ahead perhaps. A discrete signal is a mapping from the integers to the complex numbers, and we denote it by writing script z mapped to script c. So, this is you can look at the analog, just as a continuous signal maps the real axis to the set of complex numbers. So, in a discrete signal we often use the independent variable n, and we talk about x of n, square bracket. The square bracket is often used to denote the discrete nature of the signal, and we call it a sequence. Now, let me take a very simple sequence. Let me take a sequence x of n, which is 3 respectively 3, 4, minus 2 and 6 at the points n equal to 1, n equal to 0, n equal to minus 1 and n equal to minus 2. Now, let us define a very simple sequence which we call the impulse sequence. Now, this is very easy to define. This does not require any peculiarities like infinite values and so on. The impulse sequence is denoted by delta n, and that is equal to 1 for n equal to 0 and 0 else, very simple. So, in discrete time it is very easy to define this impulse sequence. Now, you can very easily see that x of n can be written as 3 times delta n minus 1 plus 4 times delta n minus 2 times delta n plus 1 plus 6 delta n plus 2. Now, liken this or bring out the analogy, see the similarity with integral minus infinity to plus infinity. You can take k going from minus 2 to plus 1. So, you could in fact put down that here, you could write k equal to 1 here, k equal to 0 here and so on. And you could say that x of n is a summation on x of k times delta n minus k, summed over the integers k. That is what you are saying here. Now, this will put things in perspective. It is easier, I think, to understand this by starting with the discrete time interpretation, which is very clean and neat, and then moving to continuous time. Now, I would encourage you, I am not giving the full explanation, I have just sort of triggered a discussion from this discussion of mine or this response of mine, and I would like some of you to talk about this. Actually, I have written this answer also partly on one of the discussions, but I would like many of you to take this discussion further and try and link the two ideas together, bring out their commonalities and differences. There is a lot of other discussion that has taken place. One observation that I would like to make is that you need to also develop the skill of deciding what kind of tools to understand what concept. Sometimes some things are better understood graphically, some things are better understood by writing down the algebra. One must learn to use both tools, both strategies, depending on the context. We will talk more as we go along, but I would once again encourage you to participate actively in the discussion. The other message that I had for all of you is, please do not get scared from slightly difficult questions, some of the quizzes. I have also conveyed this to all of you on the email. We are trying to make some of the questions challenging because we want to challenge you. We want to challenge you to think deeply, but we do not want to make the course so difficult that you cannot grasp it. So, please give us your feedback. I have asked for feedback. My teaching associates are keenly listening to your feedback, and we will moderate and modulate the questions as we see your feedback. Our aim is to give you as good the material that we can give as we can, but at the same time we do not want to make it too difficult to grasp. So, we do need to challenge you a little bit. And of course, you can always, I think you have a chance of dropping some of the quizzes and still being considered for, for the total and so on. So, getting an A grade of course should be difficult, but we think those who are diligent with the course, those who put in the required effort, should have no difficulty in completing the course successfully. That is what we feel, and we will definitely moderate the remaining quizzes in accordance with that. And we would all the time want you to engage with us to make this happen. Well, we will meet again. Wish you all the best again. Thank you.